All right, hello everyone, and welcome to the second video in our lecture series, which is going to jump back to chapter 3 to section 3.2, which is percents and all of their applications. So in this section, we are going to be looking at a lot of percent problems and a lot of applications to the real world. So most of this section is going to revolve around word problems. So you're going to find that a lot of the percent problems in this section can actually be used, can also be solved using proportions that we learned in the last section 6.6. Remember that if at any point you want to attempt a problem before I work on it, please feel free to pause the video and resume it when you are finished working. So first off, what is a percent? We've covered percents before, so here is just a refresher on what a percent is. So a percent means divided by 100, so it's parts out of 100. So you encounter percents every day, and we're going to be looking at a bunch of applications of percents, such as discounts, or partitioning of a budget, or percentages of approval. So there are a lot of different applications of percents, and we're going to be doing a lot of applications in this section. Now, percents are parts out of 100. So for example, 50% is 50 parts out of 100. So this diagram here on the lower right, there are 100 squares here, and out of those 100 total squares, 50 of them are shaded. So you can also represent this 50% as the fraction 50 out of 100, 50 shaded squares out of 100 total squares, which can also be reduced to 1/2. So percents can be written as fractions, and because you can always write a fraction as a decimal, 1/2 as a decimal is 0.5, you can represent percents as decimals. So you can change 50% into the decimal 0.5. You might remember that to change a percent into a decimal, all you have to do is divide it by 100 or move the decimal point to the left 2 places. So for percent problems, percents are never in isolation. You're always taking a percent of something. You're taking a percent of another number. So for example, let's look at 50% of 8. Well, 50% of 8 is 4. So this problem actually involves 3 parts. We have what is called the percent, which is this 50%. And then we have the base. The base is the number that you're taking a percent of. So the base is the whatever you start with before a percent is taken. So in this case, we started with 8, so 8 is the base. Now, it a lot of times follows the word of in percent problems. I will caution you though on depending on this because it doesn't always follow the word of, but very often the base follows the word of. Now the amount is what you end with after the percent is taken. So 50% of 8 is 4, so 4 is the amount. A lot of times the amount follows the word is in percent problems, but not always, so don't depend on it. But the amount is what you end with after the percent is taken. So this is going to involve a lot of translating English into math. Remember, all percent problems can be boiled down to the percent of the base is the amount. So in any percent problem, you are going to be given 2 of these quantities, and you're going to have to find the third one. So there are a bunch of different ways that these can be asked, but remember, the base is what you start with before the percent is taken, the amount is what you end with after the percent is taken, and the percent always has a percent sign. So there are 2 different ways to solve percent problems. One of them is called the percent equation. So the percent equation is the statement the percent of the base is the amount translated into math. So P times B equals A, where P is the percent as a decimal, B is the number that you're taking the percent of, and A is the number that results after the percentage has been taken. These type of problems will just involve regular division to solve them. Another way that you can solve percent problems is in this special percent proportion. So you can use cross multiplication and proportions to solve percent problems using this formula here. And make sure that you know this one. You are definitely going to need this, and you're going to be using this all the time. So the amount over the base equals percent over 100. So whatever you start with before the percent is taken goes in the denominator where the base is. Whatever you end with after the percent is taken goes up here where the amount is, and then the percent goes here. Now with the percent proportion, you do not have to turn the percent into a decimal. You can leave the percent as is, just drop the percent sign. Because it's over 100, you do not need to turn it into a decimal. Now, if you set up this proportion, you can use cross products to solve the equation for the unknown variable, because one of these parts is going to be unknown. Either the amount, the base, or the percent is going to be unknown in any of these percent problems. So we're going to start with the types of percent problems that involve you finding the amount. So in these type of problems, you know the percent and you know the base. So you know the percent and you know what you start with. And you're asked to find the amount after the percentage has been taken. So for this first one, what is 25% of 8? So we're going to figure out what each of our parts are. So first of all, the 25% here, that is our percent. This 8 here follows the word of. So 8 is our base. So our percent is 25. Our base is 8. What is, because the question word goes with the word is, the amount is unknown, so I'm going to let the variable x stand for the missing amount. So we know what we started with. We started with 8, we know the percentage, and we don't know what we ended with after the 25% was taken. So I'm going to use the percent form equation, amount over base equals percent over 100. In for amount, I'm going to put the variable x. In for base, I'm going to put 8. Equals, I'm going to put 25 in percent as is. And then the over 100 is just part of the formula, so you're going to leave it. Then I'm going to cross multiply to begin to solve this. So I'm going to cross multiply. X times 100 is 100x. Set that equal to. And then 8 times 25 is 200. Then I'm going to divide both sides by 100 to get x equals 2. So we're going to solve this next one in pretty much the same way. So we're going to start with the percent proportion, which is amount over base equals the percent over 100. So find, otherwise known as what is, 200% of 30. So 30 is what we start with before the 200% is taken, and it follows the word of in this problem. So 30 is going to be our base, so 30 will go in the denominator here. We know what the percent is, that is 200, so 200 is going to go in for percent. Over 100 is part of the formula. Find, also known as what is, means find the amount, so x is going to go in for amount. Then I'm going to cross multiply. So x times 100 is 100x equals 30 times 200 is 6,000. Then we're going to divide both sides by 100 to give us x equals 6 for our final answer. Sorry, x equals 60 for our final answer. 60 for our final answer. All right, anyway, so here's an application where you would actually use something like this. So I'm telling you right now that in this problem, we're going to be finding the amount, and I'm going to show you why based on the wording that is in the problem. So a marketing account manager has 3.5% of her monthly salary put into a 401k plan. So right away, we are given the percent is 3.5. And it's 3.5% of her monthly salary. So whatever her monthly salary is going to be the base. Not only does it follow the word of, but her monthly salary is what she starts with before she takes that 3.5% out of it. How much did she put into her 401k plan if her monthly salary is $3,200? So the base here, what she starts with before the percent is taken, is her monthly salary, and they gave us her monthly salary is $3,200. So $3,200 is the base. What we do not know is the amount that she actually puts into this 401k plan. So the amount is unknown, and X is going to go in for the missing amount. So we're going to use the percent proportion, amount over base equals percent over 100. Then what I'm going to do is, in for amount, I'm going to put X over the base, the monthly salary that she starts with, $3,200, equals the percent, which they gave us is 3.5, out of 100. Then let's do some cross multiplying. So we have X times 100 is 100X. Then we're going to cross multiply the other way. So 3,200 times 3.5 is 11,200. Then we're going to divide both sides by 100 to get X equals 112. So what this means in the context of the problem is that she puts $112 into her 401k plan every month. So in finding amount problems, you are given what you start with, and you are asked to find what you end with after the percent has been taken. Finding the base problems are a little bit different. So in these types of problems, you know the percent and you know the amount, but you do not know the base. So in these type of problems, you know the percent, you know what you end with, but you do not know what you started with. So finding the base problems will ask you to find the starting value before the percentage was taken. Keep in mind that the percent proportion has amount on the top and base on the bottom. So if the base is unknown, the variable X is going to go on the bottom. So each of these are going to involve finding the base. So 4% of what number is 8? So 4 is our percent. 8 is actually our amount, because amount usually follows the word is, so 8 is the amount. Now this is asking 4% of what number? So that means we are supposed to find the base. We do not know what we started with, but we do know that we ended with 8. So I'm going to set up my proportion, which is going to be the amount over the base equals the percent over 100. So in for amount, I'm going to put 8. Since I do not know the base, the variable X is going to go in this denominator. Then our percent is 4 over 100. So I'm going to cross multiply. So I have X times 4 is 4X equals 8 times 100 is 800. Then I'm going to divide both sides by 4 to give me a final answer of X equals 200. So 200 is what you started with before that 4% was taken. Now for this next one, 108 is 120% of what number? Notice I emphasize the is and the of. So we've got this 120%, that's going to be our percent, of what? So 120% of what is 108. So because the question word what follows the word of, we're supposed to find the base. We do not know what we started with here. 108 goes with the word is, so 108 is the amount. So in our percent proportion, amount over base equals percent over 100. 108 is going to go in for amount over, X is going to go in for the unknown base, equals the percent is 120 out of your 100. Remember, that over 100 is just part of the formula. Then I'm going to cross multiply and begin to solve. So x times 120 is 120x equals 108 times 100 is 108 with 2 zeros. Then I'm going to divide both sides by 120 to give me x equals 90. So 90 is what you started with before the percent was taken. Now here is an application problem where you would use something like this, where you would solve a percent equation with the base unknown. So let's say that a college awarded financial aid to 3,843 students, which was 45% of the total number of students enrolled at the college. So obviously, they did not give financial aid to everyone, they only gave financial aid to a certain percentage of the total number of students enrolled. We're going to find what was the total student enrollment at the college. So here's what we know. We know the percent, obviously. The percent is 45. We actually are given the amount. So this 3,843 was the number of people who received financial aid, which was not the total student enrollment. This was just a certain percentage of the student enrollment. So the amount is at 3,843. The base would be the total student enrollment at the college, the total number of students before that 45% was taken. Since we are asked what was the student enrollment at the college, that means we do not know the base, so x is going to go in for the base. So I'm going to use the percent proportion, which is the amount over the base equals the percent over 100. So the amount, which was the amount of students that received financial aid, 3,843, over the base, which is the unknown total number of students, so I'm going to put x in for that base, equals the percent, which was given as 45, out of 100. So I'm going to cross multiply, so I have x times 45 is 45x, equals 3,843 times 100 is 3,843 with 2 zeros. Then I'm going to divide both sides by 45. And I get a total student enrollment x of 8,540. So what this means is that there are 8,540 total students of the college, and only 45% of them got financial aid. So that 3,843 was 45% of the total student body, 8,540. So whenever a problem is essentially asking you to find the starting value, find what you start with before the percentages are taken, that is asking you to find the base. Now, the last type of percent problem involves finding the percent. So in these types of problems, you know the base and the amount, but you are missing the percent. There's only so many ways to ask what is the percent. The tricky part about these problems is differentiating between the amount and the base. Remember, the amount is what you end with. The base is what you start with. So you start with the base, you end with the amount. It is also extremely important that you put these in the correct spot. Amount goes in the numerator, base goes in the denominator, and then percent over 100 is on the other side. So for these two problems, they look very similar, but there is an important distinction here. So for this first one, what percent, I think it's obvious, we're finding the percent, of 80 is 60. So in this case, the starting value is 80, so 80 is your base. 60 is your ending value, so 60 is your amount. 80 goes with of, so it is the base. 60 goes with is, so it is the amount. So your proportion will look something like this. The amount, which is 60, over the base 80, equals what percent, so x is going to go in for percent, over 100. Then when you cross multiply, you're going to get 80x equals 6,000. Then when you divide both sides by 80, you get x equals 75%. So that means that 60 is 75% of 80. Now for this next one, I've switched 60 and 80 just to show you guys what would happen if you accidentally mixed up amount and base. So if you accidentally switch amount and base, watch what happens. So what percent means we don't know this x here, so x is going to go in for percent. Of 60, so in this case, 60 is going to be our base, is 80, so 80 is going to be our amount. So when you cross multiply, you're going to get 60x equals 8,000. Then we're going to divide both sides by 60. And you notice you get a very different percent. You get 133.33 repeating percent, which is very different. So the whole point of this is make sure that the amount and base are in the correct places. What you start with goes on the bottom. What you end with goes on the top. If you accidentally switch them, you're going to get a very different and very incorrect percent. So this is an example of an application problem that would directly use you finding the percent. So a college accepted 1,620 of the 4,500 applicants for admission. What was the acceptance rate expressed as a percent? So in this case, the percent is what we don't actually know. So in my percent proportion, x is going to go in for the percent slot. That means we are going to be given both the base and we are going to be given the amount. Remember, the base is what you start with, amount is what you end with. So let's start with what we started with. The college accepted 1,620 of the 4,500 applicants. So 4,500 follows the word of, 4,500 is your base. You can also think of this as you started with 4,500 total applicants, and they only accepted 1,620 of them. So this 1,620 is the amount. This is the amount of students that were accepted out of the total starting value of 4,500. So in my percent proportion, we've got the amount divided by the base equals the percent over 100. So the amount is that 1,620 over the base, which is that 4,500, equals the percent, which is x, over 100. Then we're going to do some cross multiplying. So 4,500 times x is 4,500x equals 1620 times 100 is just 1620 with 2 zeros. Then we're going to divide both sides by 4,500. And that will give us x equals 36. So in this case, this is percent, so your units are going to be percent. That means that this college had a 36% acceptance rate. They only accept 36% of the total applicants. Now, I will say that on any exams or any homework, you will not be told which one you are finding. Amount problems, base problems, and percent problems are all going to be all mixed together, and it will be up to you to figure out which one you are supposed to do. What is your unknown? So in these type of problems, make sure that you are reading very carefully and ask yourself, do I know the percent? Do I know what I started with? Do I know what I ended with? If you don't know what you start with, you're finding the base. If you don't know what you end with, you are finding the amount. If you don't know the percent, you are finding the percent. And all of these are going to use that amount over base equals percent over 100 equation. So A car depreciated or decreased in value by 20% during its first year. That's obvious. That is our percent. By how much did the value of the car decline if it cost $30,500 new? So this is why I said don't depend on there always being the word of in these type of problems, because there isn't the word of here. But we are directly given the base. So the percent is 20. Remember, the base is what you start with. In this case, in terms of the value of the car, the base is what the car cost brand new before it ever started to decrease in value. So its cost brand new was $30,500. So $30,500 is actually our base, because that's what we start with before the value declines. By how much did the value of the car decline? We don't know the amount that the car decreased in value, so the amount is unknown, so X is going to go in for the amount. So we're going to use our percentage equation, which is amount over base equals the percent over 100. So I'm going to plug in X for the unknown amount. Over, in for base is the new cost of the car, $30,500, equals, in for percent, I'm going to plug in 20 over 100. Then I'm going to cross multiply, so 100 times X is 100X. Then 30,500 times 20 is going to be 610,000. Then we're going to divide both sides by 100. And we get X equals 6,100. So what this means in the context of this problem is that the car depreciated $6,100. So its value decreased by $6,100. Tax is another example of an application of percents. So let's say that the sales tax on a $950 laptop is $71.25. What is the sales tax represented as a percent? So in this type of problem, we do not know what the percent is. So the variable X is going to go in for percent. Because we do not know the percent, we are given both the base and the amount, and it is up to you to differentiate which one is which. Remember, the base is what you start with. In this case, the base is the cost of the laptop before sales tax was applied. So this $950 here, that is what the laptop cost before sales tax. So because that was the cost before the percent was taken, 950 is your base. Now this 71.25 is the amount of tax. Notice how it follows the word is. So 71.25 here is the amount. So this $71.25 was the amount of tax that you got after the sales tax percent was taken. So I'm going to use my percent equation, which is the amount over the base equals the percent over 100. So let's plug in 71.25 in for the amount. So $71.25 in for amount over the base 950 equals the unknown percent X out of 100. So let's cross multiply. So 950 times X is 950X. And then 71.25 times 100 is 71.25. Then I'm going to finish solving for X by dividing both sides by 950. So divide by 950, divide by 950, and you get X equals 7.5. So what this means is that there is a 7.5% sales tax. Tip is another application of percents. So let's say that your bill for dinner was $36.74, and you want to leave an 18% tip on this bill for dinner. What amount should you tip? All right, so let's go through and let's identify what we have and what we are asked to find. So the percent that you want to leave is $18. The base is what you start with before the percent was taken. So in this context, the base is the cost of dinner before tip. So the cost of dinner before tip was $36.74. That is your base. That is your starting value. So $36.74 is what you start with. What amount should you tip? Means we do not know the amount of tip. We do not know the amount after the 18% was applied. So amount is unknown. So X is going to go in for amount. So we've got the amount over the base equals the percent over 100. So in for amount, I'm going to put my variable X over the base, which was the original cost of dinner, $36.74, equals the percent, which they gave us was 18, over 100. So let's cross multiply. So we're going to cross multiply. X times 100 is 100x. Then we're going to cross multiply the other way. So 3674 times 18 is 655.2. Then we're going to divide both sides by 100 to give us X equals 6.552. Remember, with money, you should always round to 2 decimal places. So what amount should you tip? You should tip $6.55. Money should really always be rounded to 2 decimal places. Commission is another application of percent. So there are a lot of people that work on commission, such as salesmen, a lot of car salesmen, real estate agents. They all work on commission. And with commission, that means that whatever sale they make, they get a certain percentage of whatever sale they made. So let's say that the owner of a condo sold that condo for $22,000. The real estate agent that they used has a commission of 6%. So that means that this real estate agent is going to take 6% of the selling price of the house. So the real estate agent is going to take 6% of that $22,000. And that is going to be what they take home as their pay. So for part A, we're going to find the amount of commission. So find the amount means the amount is what is unknown. Now the percent that the real estate agent charges is 6. The base is what you start with before the percent is taken. So the base is going to be what the condo sold for before that 6% was taken. So the original selling price of the condo before the real estate agent's commission was $22,000. We're supposed to find the amount of commission, so we don't know the amount. So in for amount, we're going to put our variable X. Then in for the base, the starting value, we started with $22,000, so $22,000 is going to go in for the base, equals the percent, they charge a 6% commission, out of 100. So let's cross multiply. So 100 times X is 100X, equals 22,000 times 6 is, it's a big number, but it's not going to be a big deal. You have a calculator. Then we're going to divide both sides by 100. So the amount that the real estate agent takes in commission is $13,320. So that is what the real estate agent is taking home as part of their pay. Now there is a part B to this. For part B, how much money did the owner make from the sale after paying the agent's fee? So this $13,320 is going to come out of what the condo sold for, and that means that the owner of the condo is going to take home the rest of it. So to find out how much money the owner took home, all you have to do is take the original selling price of the condo, $22,000, subtract the real estate agent's commission, which was that $13,320, And that will give you 208,680. So this is what the condo owner is taking home after they pay their real estate agent. Discounts are another very common application of percents. So let's say that a store gives a senior citizen a 10% discount. So right away, our percent is 10. If an item normally sells for $16, how much will the senior citizen pay? So remember, in your percent problems, you have the percent, you have the base, which is what you start with, and the amount, which is what you end with. Remember, the base is what you start with before any percents are taken. So in the context of this problem, the base is the cost of the item before the discount is taken. So the item normally sells for $16. That's the price before the discount. That 16 is your base. What we don't know is the amount, or the amount of discount X. So in your percent proportion, we've got the amount over the base equals the percent over 100. So in for amount, I'm going to put my variable X over the base, which is 16, equals the given percent 10 over 100. So then I'm going to cross multiply, so 100 times X is 100X, equals 16 times 10 is 160. Then I'm going to divide both sides by 100, and I get X equals 1.6. Now this is not what the senior citizen pays. This 1.6 or $1.60 is the amount of discount. So the amount of discount is $1.60. This is only what the cost is decreased by. So the cost of the original item is decreased by $1.60. That is not what the senior citizen pays. To find out how much the senior citizen actually pays, you're going to take the original price of the item, $16, subtract the amount of discount, $1.60, and then you get 14.4, so $14.40 is actually what the senior citizen pays. So just be very careful of these types of problems. In discount problems, the amount is going to be the amount that the price was reduced by. To find the sale or discounted price, you have to take that amount of discount and subtract it from the original item's original price. Politics also involve a lot of percentages. So let's say to override a presidential veto, 66 2/3% of the Senate must vote to override the veto. So the percent that is needed to override this veto is 66 2/3%. There are 100 senators in the Senate. What is the minimum number of votes needed to override a veto? So remember, the base is what you start with, and the amount is what you end with. In this context, the base is the total number of senators before any voting happens. So there are 100 total senators in the Senate, so your base is your total value, 100. Now the amount, we don't know what the amount is. We don't know how many votes are needed to override a veto. So what is the minimum number of votes needed? We do not know the amount. So in our percent equation, we've got the amount over the base equals the percent over 100. So in for amount, I'm going to put X. In for base, I'm going to put the 100 total senators. Equals, in for percent, I'm going to plug in 66 2/3. And then over 100 is part of the original formula. So let's cross multiply. So X times 100 is 100X. Equals 100 times 66 2/3 is, oops, no, hold on, give me a second. There we go, 6,666.6666, and repeating. Then we're going to divide both sides by 100, And here's what the calculator gives you. The calculator gives you x equals 66.666 repeating. However, this is the number of votes that are needed. Votes are cast by people. People are in whole numbers. So you should really round up to the nearest whole number. So 67 votes are needed to override a presidential veto. Pharmaceuticals, or anything else where you have a compound that has a certain percentage of different materials, is also an application of percents. So let's say that a pharmacist has 40 grams of a topical cream that contains 65% glycerin. How many grams of the cream are not glycerin? All right, so in this type of problem, again, this is a percent problem, so we're going to have three parts. We have our percent, we have our base, and we have our amount. So let's get the percent out of the way. That's 65. So percent is 65. Now the base here is the total amount of cream before you start looking at any percentages of it. So the 40 grams of a topical cream means base is 40. So the base is the total amount of cream before you start looking at glycerin, not glycerin. How many grams of the cream are not glycerin? So we don't know the amount. We're given the base and we are given the percent. So in our percent equation, we've got amount over the base equals the percent over 100. So in for amount, I'm going to put x. In for base, I'm going to plug in 40. Equals, in for percent, I'm going to plug in 65 over 100. So let's do some cross multiplying. So x times 100 is 100x equals 40 times 65 is going to give us 2600. Then I'm going to divide both sides by 100. And I get x equals 26. However, I'm not going to circle this because this is not actually my final answer. So that 65% was the percent of glycerin. Now, anytime you're doing a percent problem, that 65% deals with glycerin. So this 26 is the number of grams of glycerin. To find how many grams are not glycerin, you have to do a little bit more work. So the total number of grams of cream that we have is 40. And then if you subtract out the number of grams of glycerin, 26, you will get the number of grams that are not glycerin. So there are 14 grams that are not glycerin. So just be very careful that you are actually answering the question and that you are paying attention to the wording of the question. The last application of percents that we are going to do is something called simple interest. So there are different types of interest. There you have simple interest and you have compound interest. Compound interest you will learn in later courses, but we're going to do simple interest in this class. So what simple interest is it is money that is credited to your account and is a certain percentage of the principal. The principal is the amount of money that is originally deposited into the savings account. Now, when money is credited to your account, that means they give you money. So they're going to take a certain percentage of the money that you initially deposited into your account every single month. So the formula for simple interest is I equals P times R times T, where I is the amount of interest earned, P is the principal or the amount that is originally deposited, R is the interest rate as a decimal. Now, simple interest has its own formula. So simple interest, we are not going to be using the proportion that we've been using for this whole lesson. Simple interest is going to have its own formula. I equals P times R times T. And in this formula, your interest rate needs to be a decimal. Now, most of the time, your interest rate is going to be given as a percent. You have to turn that percent into a decimal before you plug it in. Do not plug a percent into this formula. You need to divide it by 100 before you plug it in. So to turn a percent into a decimal, you're going to divide it by 100 or move the decimal point to the left 2 places. And then in this formula, T stands for the amount of time in years. So this is an example of a simple interest problem. So a customer deposited $825 into a savings account that each year pays 5.1% in simple interest. So to figure out when you're supposed to use this, you look for those 2 keywords, simple interest. As soon as you see the words simple interest, you're going to be using the formula I equals P times R times T. What is the account balance after 2 years? All right, so in simple interest problems, there are 4 variables here, so we're going to figure out what we know and what we don't know. We're going to figure out what we are given and what we are asked to find. So a customer deposited, that's a keyword, $825 into a savings account. That is your principal. That is what was initially deposited into the account. That pays 5.1% in simple interest. So your R is going to be that 5.1%. However, to turn 5.1% into a decimal, you do need to move the decimal point to the left 2 places to give you 0.051. So the R that you're going to be using in our simple interest formula is 0.051. Then what is the account balance after 2 years? So T, which is the time in years, equals 2. What we don't know here is the amount of interest. We have no clue what this person earned in interest over these 2 years. So interest is unknown. So in my interest formula, I'm going to leave I alone. So in my simple interest formula, I have I equals, I'm going to take 825 and I'm going to plug it in for P, use parentheses. Then in for R, I'm going to plug in my interest rate as a decimal, so 0.051 is going in for R. And then in for T, I'm going to plug in the number of years too. And you have calculators that are powerful enough to just do all of this multiplication all at once. So just do all of that multiplying all at once, and you get an amount of interest of $84.15. However, this is just the amount of interest that this person earns. This is not the account balance. If they don't make any withdrawals, the account balance should not go down. This is the amount of interest. To actually find the account balance, what you are going to do is you are going to take the initial deposit amount, the $825 principal. You are going to add to it the amount of interest that was credited, so you're going to add to it $84.15, and then that will give you the account balance. So the account balance in total is $909.15. So just make sure that you are reading the question carefully and that you are fully answering the question and doing exactly what you're supposed to do. The simple interest formula, I is the amount of interest, which if the problem is asking for the amount of interest, then great, that's your answer. But if the question is asking for account balance, you need to take the amount of interest and add it to the principal. Now for this last one's going to be a little more complicated because we have 2 different accounts with 2 different interest rates. So Matt decided to divide a gift of $3,000 into 2 different accounts. So he's given $3,000, he's going to split it up between 2 different accounts. He places $1,000 into one account that earns a simple interest. It has a simple interest rate, so simple interest, as soon as you see the word simple interest, you're going to be thinking, I'm going to use this formula, I equals P times R times T. That has a simple interest rate of 8.5%. The remaining money was placed in an account that earns an annual simple interest rate of 8.75%. How much interest will Matt earn from the two accounts after 1 year? So the amount of money is put into both accounts for 1 year, so the time is the same for both. However, because these are two different accounts with two different interest rates, I am going to split this up into two separate problems at first, and then we will combine it later. So for the first account, we have no idea how much interest was earned out of the first account, so interest I is unknown. P is going to be the amount that is deposited into the first account. So the first account, he put $1,000 into it, so $1,000 is the principal for the first account. Now that first account has an interest rate, so that is R, of 8.5%. So 8.5% is your R. However, to turn 8.5% into a decimal, you need to divide it by 100, which gives you 0.085. Then the T, the time that this is left in the account is 1 year, so T is equal to 1. So we're going to then plug all of this in to the simple interest formula, I equals P times R times T. So I is going to equal the principal, which was 1,000, times the interest rate as a decimal, 0.085, times the T, which is 1 year. Plug all of that into a calculator and you get an amount of interest of $85. So that is the amount of interest that the first account earns. Now to find the amount of interest for the second account, we're going to do basically the same thing. The second account has not only a different interest rate, it also has a different principal. So for the second account, we still don't know how much interest was earned, so the interest amount I is unknown. For the principal, remember, the total gift was $3,000. He just put $1,000 into the first account, which leaves $2,000 to be put into the second account. So that's what the remaining money means. So after that $1,000 was put into the first account, the rest of the $2,000 was put into a second account that earns an annual simple interest rate of 8.75%. So that is going to be your R. So I'm going to turn 8.75% into a decimal by dividing it by 100. So that is 0.0875. And then once again, the time is still 1 year. So I'm going to plug all of this into the simple interest formula to find the amount of interest earned from the second account. So the interest on the second account is going to be the principal, 2,000, times the interest rate as a decimal, 0.0875, excuse me, times the time, which is 1. Plug all of that into a calculator, and after all of the multiplying, you get 175. So he earned $175 in interest just from the second account. Now, the question is actually asking, how much interest will Matt earn from the two accounts? So from the two of them put together. So the total interest is going to be the amount of interest earned from both accounts added together. So the total interest is going to be $85 from that first account, plus $175 from that second account, gives us a total amount of interest of $260 from the two accounts put together. So that is it for section 3.2. Section 3.2 is all about percents and their applications. So for this section 3.2 homework, you will not be told whether you are finding the base, the percent, or the amount. It will be up to you to figure out what you're supposed to find. Remember, the base is what you start with, the amount is what you end with. Now, in addition to the homework that is posted on Canvas and WebAssign, I also have some additional practice problems specifically dealing with percent problems. These additional practice problems are not required, but I do highly encourage you to do them to prepare for the next exam, because there are going to be a lot of percent problems on the next exam, and quite a few, and they're all going to be word problems. So definitely before the next exam, take some time to do the additional practice problems for the percent problems for section 3.2, and then you should be pretty much set for at least this part of the exam. So that is it for both ratios, rates, and proportions and percent problems. After this, we are going to be moving on to a completely different topic, which is section 6.7. So make sure that you wrap up 6.6 and 3.2 before you move on to the next section. So if you have any questions, feel free to send me an email, and I will see you all in the next video. Bye-bye.